Okay, guys, good morning. It's Mr. Willis here. I just wanted to kind of get you guys set up for this week's lesson. So I'm going to go over the other stuff from last week really quickly, and then I'm going to kind of move on because long videos don't do very well with you guys. All right, so excuse me, the assignment from last week was to complete the rock cycle stuff. I know some of you still have to work on that. I know I'm giving you guys a lot of material. I'd rather give you too much work so you have stuff to work on throughout the week. Obviously, if you don't finish it within that week time frame, you can continue to work on that as it moves on. I tried to build in a day in the lesson so you guys can go back and work on some of those materials. So make sure you go back and go over the question review, look at the rock cycle video, do those particular things. All right. So what we're going to cover today is going to be a heat transfer review. So what I'm going to start trying to do is get you guys a little more ready for physical science next year, since that's what the majority of you are going to be taking. So we're going to go back and talk about the first and second 9 weeks when we talked about heat transfer, and we're going to talk about how that transitions a little bit into the physical science side of stuff for you guys as we move forward. So this is going to be a little bit shorter video, I think, than the others, but I do have some extended materials that you guys will be able to go over in a little bit. So just quickly to kind of get started. So we're going to talk basically about thermal energy here, and what we have with thermal energy on this particular part here is that, again, we're talking about the kinetic energy inside a particle. The more heat it has, the more those particles are moving around, the more they bump into each other, the more they collide, which causes an increase in the temperature of an object. And remember, heat is going to transfer always from hot to cold. So if you take a hot thing and you move it into a cooler area, that material, that heat, is going to begin to transfer into that other material, and it's going to transfer into that other medium. And a medium is whatever material, or just material, I guess is the best word, that it's going to transfer into. So there's three types of heat transfer. We've talked about those before: conduction, convection, and radiation. So what I've done here is kind of set this up for you. So let me, I'm going to zoom in a little bit on this. This is the notes that I created for you guys for this week, so you can take a look. So again, and we'll kind of basically just shoot through these pretty quickly so you guys are in a good shape as far as that goes. All right, so conduction, right? When we talk about conduction, we're talking about direct contact, right? So we're talking about two things physically touching. So in the little picture that I have for you guys located right here, what we can see here is this hot rod was sitting inside the fire. So the heat was conducting into the rod itself, and then this person decided to grab the hot thing. And that obviously is going to cause heat transfer because that rod is significantly hotter than his hand, or his or her hand, and that energy is going to transfer into that. So you're going to get a direct transfer of those things. Heat is going to transfer from hot to cold. It's just how thermodynamics works. So conduction is not possible in a vacuum, so it doesn't work in space. It has to have something to transfer, so you have to physically be touching. Touching is kind of the thing that we're taking a look at right here. So good conductors allow heat to pass through faster. Typically, good conductors of electricity are also good conductors of heat. Bad conductors are things like wood. Think about plastic. When we use those plastic or oven mitts or anything that you're going to grab something hot with, you don't want the heat to transfer through quickly. So you're trying to slow that down. So insulators are going to be kind of the bane of a conductor's existence, right? So that's what we're looking at right there. All right, so let me scoot this down. The next one we're going to take a look at is going to be convection. Convection, if you guys can think back to whenever we heated the material and created the thermos back in FOSS, convection occurs in liquids and gases primarily. And as I've been talking about over the past couple of weeks with you guys, we also see convection occurring in the mantle because that solid acts, it behaves like a fluid. And over long periods of time in the Earth's mantle, we get these huge currents. Now, obviously in liquids and in gases, this is going to happen a little bit more quickly in those materials because those materials can move more freely. Sorry if you hear my dog barking in the background there. He's a little active this morning. All right, so heat transfer. Convection currents usually set up in a fluid and a gas. Hot things tend to move up because they're less dense. Cold things tend to sink because the particles are closer together and they're more dense. And it creates these rotating currents. So the video that I have tagged into one of the things that I'm using for you guys, you'll be able to see that through the little visualization. Down here is a neat little video for those particular things. The transfer of heat is always vertically upward. So it's going to move upwards and then it's going to rotate downwards. Think of a crawfish pot. Think of a boiling pot of water for spaghetti. All of those things. The heat's going to, through conduction, it's going to heat up the bottom of the pot. It's going to convect in the water. It's going to go up, and then it's going to convect back down. So you're going to get that upward movement, and then you're going to get a downward movement of dense particles that's going to move down. So you're going to have your denser particles here, and you're going to have less dense particles that are going to move up through the heat current that we see there. All right. So those are pretty easy to understand. Those are things that we physically messed with at the beginning of the year. So that should be a bit of a review for you guys. All right. So radiation is the one that I think gets a little confusing for some students because it's kind of hard to understand. What I want you to think about is if we go outside, we were to blindfold you, and you wouldn't know where the sun was. Would you be able to figure out where the sun is? And the answer to that question is yes, because you would feel the heat from the sun. You wouldn't necessarily see the light, which is one type of radiation, but you could see or feel the heat as it hit your face. So that's something that's going to be important. So radiation is the third type of heat transfer and arguably one of the more important ones because this is how we get energy from the sun. The sun doesn't touch the earth. There's no gas or no liquid between us and the sun. So the only way for the heat to transfer to us is through the vacuum of space. And radiation is going to do that in the form of electromagnetic waves, which is really, really important. All right, so one thing I wanted to note, because this is something I would have made a big point of in class, is this is not the radiation from nuclear weapons or from any of those things like that. This is electromagnetic waves that are traveling through a vacuum. They can travel through mediums. Light can travel through liquids, but it's going to do that. Whenever we're talking about radiation for like nuclear weapons, we're talking about particle radiation. We're talking about very, very high energy X-rays and gamma rays, which kind of tie in, but they're not all the same things that we're talking about. But the really bad stuff, alpha and beta particle wave radiation, are going to be the really, really bad stuff when we talk about that. So what I want you guys to understand is that everything takes in energy from around us, and that's primarily going to be done through radiation. And everything is trying to balance. Remember, if you take a pot of hot water off the stove and you leave it on the counter for a couple of hours, it's going to begin to reach equilibrium. That heat is going to radiate out into the room, and it's going to balance that temperature with the outside temperature that we're seeing there. So that's going to be really, really important for you guys to kind of get a grasp on. So the image that I have for you down here are some basic examples of some radiations that you guys would be pretty familiar with, I think. So a microwave oven uses microwaves, which are a form of radiation. Remember, we talked about the electromagnetic spectrum at the beginning of the year. That's what I'm really going to go over next week. It's going to be our big lesson. But remember, microwaves are relatively low energy forms of radiation. We use them to communicate with satellites. We use them to cook things in our microwaves. And that's going to be really important. So microwaves and radiation from the sun to the earth. And I think this is obviously the big one that we need to be aware of. But heat, we're talking about things like going from the lower end or the very large wavelength stuff to the very powerful stuff at the end. We're talking about radio waves, microwaves, infrared energy. We're talking about visible light. We're talking about UV or ultraviolet rays, X-rays, and gamma rays. Those are the types of radiation that we're talking about in these particular instances. But when we're talking, and all of those can transfer energy, and that's really, really important for you guys to understand. So that's what we're talking about here, the transfer of heat and the transfer of radiation. And heat is going to be one form, that infrared energy, that thermal energy is going to be one form of energy that we see in the electromagnetic spectrum. All right, so down here at the bottom, what you guys hopefully see here are a series of links that I have created. It's got some Kahoots and some Quizlets that you guys can work on throughout the week. And I've got some physicsabout.com, which is a really interesting it's a great little site if you have some questions about some physics topics. So this could be something you guys could certainly use next year in physical science and whenever you guys are 11th or 12th graders and you're taking your physics class. So just real quick basic examples. So conduction of heat transfer through conduction. So I have some examples right here. Utensils, grabbing charcoal, ice in a cup of water, all of those particular things where heat is going to conduct through those particular examples. Convection, right? So hot tea or coffee, a land and sea breeze. This is something that we would have talked about in greater detail. And you guys would have learned it last year with Miss Smith when you guys would have learned about heat transfer between the differences between, and again, if you've ever been to the beach, you can feel it's always windy because heat is transferring in. The beach heats up much quicker than the water does, so that hot air rises, so cooler air comes in off of the water. So that's why we tend to see those things. So the land and sea breeze is caused by convection. And then again, the Earth's mantle, all of those particular things. So this is a great example. This little video down here, really, really great example of how convection occurs in a liquid. So you guys can go take a look at that one if you like. And then radiation examples, right? So heat from a fire. If you've ever been next to a bonfire or even just a fireplace, feeling that heat. hit your face if you've been in it. It's really cold outside during the winter and you go stand by a window and the sunlight's pouring through, you start to warm up. That's an example of the radiation, that energy that you're getting from the sun there. So that's what we're looking at in these particular instances. So these 3 websites are all linked within the document that I provided to you guys, so you guys will have just some extra sources to go over those particular sets of material. All right, so real quick, let me drop over here. I'll have the student assignment I'm going to drop. I'm actually going to attach this for you guys. I think it might be a little easier. I've been working with this to try to get it onto my website. Again, go to my website to get the assignment. Obviously, if you're in the Google Classroom, you can do that. But again, so you can take a look at these particular things here. This is kind of the tentative assignment for the week. You're going to watch this little video on Monday and highlight and annotate the notes. On Tuesday, you're going to complete the first Quizlet and the first Kahoot, which the links are right here. You can click on them and go directly to them. On Wednesday, I've got a Khan Academy thermal energy note set that you guys can take a look at. It's a lot shorter than my notes, but it's really well done. So I wanted to provide that as a resource for you guys. And there's a really good little Khan Academy video on heat transfer. He does a really good job, probably better than I do, on explaining those things. So he's got really good graphics you guys can take a look at. So if you've got some questions or you need some additional help with it, you can go through that. I'll have a 20-question problematic little quiz for you guys to finish on Wednesday, and all of this is going to be posted over this weekend, and you'll have all week to work on it. Thursday is my kind of remediate day. Go back and finish the things that you haven't finished, right? So there's plenty of work in the Google Classroom, and a lot of you still have some stuff that you need to finish in there, so do yourself a favor and do that. Friday, I'll have a second Quizlet and a second Kahoot about the electromagnetic spectrum. I'm going to use this one as kind of a pretest to see what you guys remember and know about the electromagnetic spectrum from 6th grade and from this year. So do that, complete that, and get that sent to me. So as always, send me any questions that you might have. I'll try to put a video together for that to get those particular things done. So I'm going to try to attach this document to there as well so you guys can work on it. Again, that's about it, guys. So I know this video is about 10, 12 minutes in that range. That's where I'm going to try to keep them from now on to keep your attention. I hope everything's going well for you guys. I miss you guys. Hope everything's... I hope you guys are getting ready to end it on a good note. So take care of those particular things. If you've got some questions, as always, send them to me through the Google Classroom. Stay safe. Check your sources, as always, remember, and have a good week, guys. So take care. I'll talk to you later. Bye-bye.